Hello everyone, my name is Maurice and this time we're going to talk about variables. We continue where we last stopped, at the command window. In Matlab, a variable is defined as a row or column vector or a matrix, so it can also be a single number. In case you don't know what that means, don't worry, you will get it later, and for now it's not important. A variable can be compared with a placeholder. You can assign variables in a simple way. By typing in x equals 3 and pressing enter, we define the variable. This newly assigned variable is also displayed in the workspace. Matlab returns your command after executing it. The variable is created as a 1x1 matrix named x and stores the value 3. Another example is x equals sqrt 16. As you can see, the result is 4. But what does sqrt even mean? We can use the help function to see what a function is doing. We type in help sqrt and confirm with enter. We can see sqrt means square root. So we get the square root of 16, which is 4. If you only need a few information, using the help command will get you there. Still lost? Try the doc command. Doc opens the documentation, which will present you a description. Additionally, you can also see examples on how to use the function. The documentation includes even more information, but this is not important for now, so let's close the documentation. You should know a few things about variables in Matlab. First, once a variable is saved, you can refer to it later. You can see the current variables in the workspace. Secondly, variables must have a value before they are used. This is really important for scripts. And lastly, when an expression returns a result that is not assigned to any variable, the system assigns it to a variable named ans. Like mentioned before, ans stands for most recent answer, so it only saves the most recent answer. So be sure what the most recent answer was before using it. In general, you should avoid using ans. Let's take another square root, but this time we don't assign it to a variable right away. We type in sqrt parentheses 99. The result is saved in ans and we can now use it to multiply it with 7. The new result is 69.6491. However, multiplying ans again with 7 will give us 487.5438, because the last answer was not from square root 99. By the way, when the command window is active, you can use the arrow keys to go through your command history by pressing up and down. We can also save ans in a new variable. For example, we can type in x equals ans. Another side note is that you can suppress the output in the command window by using a semicolon. This is in particular important for writing scripts. If we repeat everything from before, but this time we use the semicolon, we don't see any output in the command window. Instead, we can check the workspace for the current value of variables. Because we defined x already, we can refer to it in any new calculation. For example, we can type in y equals x plus 500, which equals 987.5438. Here you can see a list with quite commonly used operators and special characters. In the course of this tutorial, we are going to talk about all of these operators. Starting from now, we are going to mostly use the editor, and the command window will only be used to test commands. A script has some obvious benefits. For one, we can easily repeat it. Another benefit is that we can change things later. And most of all, most scripts are way too long to always type it into the command window. Okay, now let's use the editor, and we start by assigning several variables. A equals 2, B equals 5, and C equals A multiplied with B. Okay, we can almost run our first script. Usually, programming tutorials start with the famous hello world command, but for Matlab this makes no sense. We actually have several ways to run our script. In the editor tab there's a green play button which runs the script, or we can simply press F5 to run it. Hovering with the mouse above the icon also shows what this button is doing and the hotkey. Note that we use semicolons for the assignment of A and B, so there is no output for the variable assignment. However, C does not have a semicolon. Therefore we can see the result in the command window, namely C equals 10. Interestingly, you can assign multiple variables in one line, but only when you separate them with a semicolon. This way you can save space. You might already have noticed the red line below the equal sign. Simply hover with the mouse over the line and the tooltip will tell you what this is about. In our case, Matlab is suggesting to use a semicolon within a script to suppress the output. Since this is only a warning, we can ignore it and run our script anyway. This warning is also indicated in the top right corner of the editor by the orange or yellow square. The square can basically have 3 different colors. If it's green, everything is fine. If it's orange, there's a warning, but you can still run your script. But if the square is red, something is wrong with the syntax. Therefore you cannot even run the script anymore. Below the square, you can see a small orange line next to the line where the warning is in. Hovering above this line also shows you the warning and gives you the specific line. After all this, we might forget which variables we already have. But you don't have to worry about this, because there are yet again multiple ways to solve this problem. For one, we can use the who command in the command window, and it shows us only the names of the variables. If more information is necessary, you can use the whos command to see the size of the variables as well as the bytes it takes to save them, and lastly the class. Another easy way is to simply look in the workspace, and this is my personal favorite. Frankly, I rarely use who or whos,